So for example, to show you how you will make it work, regardless the number was stored over here or not, you will write some code like this. If a list of 2 is int. Okay, if that's the case, then what will you do? Int num equal to int of a list of 2. So again, you can use the is operator or the as operator or reflection to figure out, is it really pointing to an integer? Okay. So once again, keep in mind, is, as, reflection are expensive runtime operations because they have to go through the vtable to the type info to actually find out it is pointing to an integer, right? Okay. So anyway, now let me come to a loop. And let's take a look at the same example. And so let's make it even interesting. Let me create another example so that everybody can fully understand it. Okay, so let's create an example. Suppose it looks like this, array list. A list equal to new array list. So we create an array list, right? Then we say, let's create a student. Student S1 equal to new student. And suppose we set test1 equal to 89, test2 equal to 91. Okay, and the formula goes like this. It's 0.4 times test1 plus 0.6 times test2. If that's the case, if it's greater than 90, then it's an A grade. Okay, so that's how the compute grade was written. Okay, so then we do a list.add S1, correct? Now we create one more student, S2 equal to new grad student. Okay. We do S2 dot test1 also 89, S2 dot test2 also 91. Okay, and let's pretend for the grad student it's 0.5 times test1 plus 0.5 times test2. And if this weighted average is greater than 90, then student will get an A grade. Otherwise A minus. Okay, and so on. So now let's go a list dot add S2. Okay, so suppose our goal was to loop through the array list. So now let me come to the loop and call compute grade or print the grade of every student who's stored in the array list. Okay, so we can write a regular for loop. Our regular for loop will look something like this. For int I equal to 0, I less than, we called it a list dot count. So just like an array has the length property, the collection, all collections have a count property, which lets us know how many elements are stored in the collection. So in this example, what will be the count? 2, right? Because we stored one time S2, one time S1, so 2. So it will go through I of 0 and I of 1. Okay, so first time through the loop I will be 0, second time through the loop I will be 1, right? So what if I did something like this, message box.show, and a list of I dot compute grade, what will happen? Will this code compile or won't even compile?
This will come.
Okay. What data type is a list of I?
Object.
Object. Remember, if anything that's stored in the array becomes an object, so it's an object. Does an object have a compute grade method? So the code won't even compile, right? In this example, we know everything we were storing in the array list was a student, right? What if we do this? We typecast it to a student. So we typecast it to a student. And then further, let me put one more parentheses over here, one more parentheses over here. So see, now if you take a look at inside the parentheses, we converted object to a student, correct?
Yeah.
Now if we call compute grade, remember this has become a student now. Does student have a compute grade?
Yes.
So it will work. So first time through the loop, what will it print out? What grade will it print out in this example? A. Second time through the loop, what will it print out?
A.
No, because 0.5 times 89, 0.5 times 91 is exactly 90.
Yep. A minus.
But we have to be greater than 90 to get an A.
A minus.
So it will print out A minus, right? Okay, so that's one way of looping through, right? There's another loop, as I mentioned, there's another easy loop available, especially for dealing with collections, called the for each loop, okay? The for each loop looks like this. For each student st in a list and message box dot show st dot compute grade. Okay, so this is what the for each loop looks like. Okay, to understand the for each loop, let me draw the picture. Right now, you have S1 stored over here, you have S2 stored over here in the array list, right? So think of this for each loop as student st. We are creating a reference called st, capable of pointing to a student. Once we say st in a list, what it will do is, very first time through this loop, it will point to the first element. Okay, is this a student? Internally?
Yes. Yes.
Yes. I mean, even though it's stored as an object, internally it is a student, right? It will call the compute grade and it will print out just like before an A. Okay. Then second time through this loop, our reference will change to the second object in the list. Is this also a student?
Yes.
Yes, so we'll call the compute grade on it. It will print out A minus over here. So which one of these is easier? The for loop or the for each loop? For each is easier, you don't have to worry about typecasting it, right? However, in both cases, we can run into a complication, okay? So for example, suppose this code was working perfectly, okay? Then somebody went and added one more thing to the array list. And let's take a look at, in both situations, what will happen. So now, let's go to this part over here. Okay, very first time through this loop, it will go to a list of 0, right? This is index 0, this is index 1, this is index 2, correct? So as we are looping through this one. Count, of course, is 3 now because there are 3 things stored in the A list, right? Very first time, A list of 0. Can we convert this to a student? Can we typecast it to a student?
Yes.
Yes. So we'll print out
A.
A. Second time through this loop, I will become 1. A list of 1. Can we convert A list of 1 to a student?
Yes.
Yes. We'll call the compute grade and it will print out A minus. Third time through the loop, when I becomes 2, A list of 2 is what?
Hello.
Can we typecast it to a student?
No.
So what will happen?
Runtime.
Runtime error will occur, so your program will crash after it goes third time through the loop. Okay, let's go to this scenario over here. Okay, again, very first time through the loop, ST will be pointing over here. For each student, ST in A list. So first time through this loop, it will point to S1. It is a student, so it will print A, no problem. Second time through this loop, ST will point to the second object. It is a student, it will print A minus, no problem. Third time through the loop, can ST point over here
No.
to a string?
No.
So again, it will generate a runtime error, right? So in both cases, we have to check before we blindly either typecast it or try to call a method on it, okay? So the proper technique in both cases will look something like this. Here you will say, for example, you can do student ST, well, let me call it student STU so that you don't get confused, equal to A list of I as student. Okay, if STU not equal to null, then message box dot show stu dot compute grade. So we will change the code to look like this. Okay, now let's take a look over here. Very first time through this loop, when I is 0, A list of 0, can A list of 0 be successfully converted to a student? Yes. So then stu will point over here, correct? And since it's pointing into an object, obviously it's not null. So message box.show stu.compute grade, will it print A?
Yeah.
Yes. Second time through this loop, student S2 equal to A list of 1. What's A list of 1? So stu is pointing over here in the second time through the loop. Correct? And can this be converted to a student? Yes, so stu will point over here. So it will print out A minus, no problem. Third time through the loop, I will be 2. When I becomes 2, what will our code do?
Null. Return null.
It will return null. So since it's null, will it call the message box? No, so we'll simply ignore this and print A and A minus. That was the goal, right? If it's a student, call the compute grade on it. Okay. Now let's go and fix the second loop for the same thing. Because we'll be doing more than one thing, begin curly and curly are required. Remember, in a for or for each loop, if you're only doing one thing in the loop, begin curly and curly are optional. Okay. So anyway, so same thing we'll do. Okay. So suppose we do something like,
ST equal.
okay, but see over here, we already there's another problem, okay? Regardless of what code we write over here, it will always run into a runtime error. Why? Because first time through the loop, can ST point to S1?
Yes.
Yes. Second time through the loop, can ST point to S2? Third time through the loop, because remember we said keep pointing to every element in the A list. Can ST point to hello? No, because it's a string, this is a student type reference, so it will always generate a runtime error. So one thing you need to do is if you have to pick a reference so that it can successfully point to everybody over here, it has to be base class of all of these objects. What's the base class of student as well as string? Object. So first thing we will need to change is make this object OBJ. So now if we are creating an OBJ type of reference, can it point to the first element?
Yes.
Can it point to the second element?
Yes.
Can it point to the... Remember, everything becomes an object anyway. So the loop will succeed, okay? Now suppose some were students, some were grad students, some were part-time students, or let's pick another example. Suppose that you have some E-list over here. You had a part-time employee, you had a full-time employee, you had a staff object over here, right? And let's pretend the base class of all of these is an employee. Then how will you write the for each loop? You will say for each employee EMP in E-list. And then, so can EMP point over here?
Yes.
If part-time is derived from an employee, then yes. Okay, can EMP point to over here?
Yes.
Can EMP point over here? If all three are inheriting from the employee class, remember base class reference can point to a derived class object, right? But what if we added one student over here? So this is of type student, which is not derived from employee. Then what will happen to this loop? First 3 times it will be successful. Once it goes to the EMP goes over here, what will happen? Runtime error. Because student is not inherited from employee and EMP is of type employee. So how should we fix it so that it can point to each and everything over here? Change this to whatever is the base class for student as well as employees. If you cannot think of anything, any common base class, the top level base class will always work because everything is ultimately inherited from the object class, okay? So now you can sort of understand why they made a single class as the ultimate base class for all classes. Doesn't matter where you are, ultimately everybody, so this way our loops will always succeed if we use the object, right?
It's like that for C++ too, right?
C++ is different. It does not have a single hierarchy, but anyway, let me finish this, then I'll stop. So for each object, OBJ and A-list, so now it's an OBJ. So now you will further have to do something like this. If OBJ is student, or you can use the as operator, since I already gave you the as example over there. Let me pick the is operator. So now you will say student st equal to student obj, and then message box dot show st dot computer. Okay, so again we are checking, and if we are pointing to a student, If OBG is a student, only then we typecast and obtain a student type reference. So what will happen third time through the loop when OBJ is pointing over here?
No.
Will is operators
No.
return true?
No.
No, so we'll skip this part, right? So this is the main concept in collections. Once again, collections are flexible. Restoring data is easy. Recovering data, you do have to do some type checking and typecasting. Okay? We'll continue from here. For your current assignment, I have to cover a few more things because I would like you to do unit testing on it. So the due date for the current assignment will be the following Monday. On Wednesday, I'll cover the unit testing, so hold on to it before you submit it.